2 to the x power is reflected across the x-axis, shifted up 2 units, and then shifted to the left 3 units. Write an equation for the new transformed function. So f of x equals to reflection across the x-axis. That means the function was negative, and then we're going to say shifted up, which means we're going to add 2 units to the function itself, and then x here shifted to the left, so we're going to add 3 units. So that is the function. What is the y-intercept? To find the y-intercept, you're going to put x is equal to 0. So if you plug that in, you're going to get y equals -2, 0 plus 3 plus 2, which will give you -2 to the 3rd power plus 2, which is -8 plus 2, and that is -6. So the y-intercept is going to be 0 and -6. And for just being curious, I'm going to find the x-intercept. So to find the x-intercept, we're going to put y equals 0, which means 0 equals -2x plus 3 plus 2. So now we're going to subtract 2. We're going to get -2 equals -2x plus 3. Notice that we have the same base, so I'm going to make the exponents equal. The exponent here is equal to the exponent here, which is, if it's not written, it's 1. So x plus 3 equals 1. So x equals 1 minus 3, x equals -2. So the x-intercept is -2 and 0. What is the domain of the new function? The domain does not change for the exponential function. It's always from -infinity to +infinity, despite of the transformation. The range of the exponential function, notice how the function moved up 2 units and it was reflected, which means it'll go from -infinity to 2, not including 2. Now, to graph that, we're going to graph the horizontal asymptote. The horizontal asymptote is y equals to 0, or y equals to 2, sorry, which is the vertical transformation. So that is the horizontal asymptote. And remember that the function was flipped over. So now we have the y-intercept, which is 0 and -6, approximately here. And then the x-intercept is -2 and 0. So the graph of the function is going to look something like this, approximately. And that confirms our range and confirms our domain. For the function f of x equals 2 to the 5 plus 3x, find f of -2. So to plug that, we're going to say 2 to the 5 plus 3 times -2, which is going to be 2 to the 5 minus 6. That is 2 to the -1. And we're going to write it as a fraction. So we know to turn the exponent into positive, we push it into the denominator. So it's going to be 1/2. So that is the answer. The answer is 1/2. The function to the graph. I'm going to begin with these functions that are declining, or this is a decay function. The decay function has a base less than 1, so these might be the ones. Now it's just a matter of determining which one is which. Immediately I can tell that C, which has a y-intercept that is bigger than the other ones, so that is 4. I can immediately say that this is C. This is function C. Now, to determine if A and B, out of these, we're going to look at which base is bigger. So notice how this function has a bigger base than this function. So this function right here that I'm going to highlight is the one that is the closest to the y-axis, which is B in this case. So this function is B. That leaves me with A for the remaining one. Now, similar approach I will look at the growth functions. So these are the growth functions, and I can immediately tell that D, which has the biggest y-intercept, is this one, because that is 4, and the other two are 2's. Now, to distinguish between this function and that function, we're going to compare the base. The base here is bigger, which means it is the closer function to the y-axis, which means it's E, and that remains, the remaining one is F.